Good evening, everyone. Myself, Vishal Yadav, Assistant Professor in Department of Computer Science and Engineering and Artificial Intelligence uh, from IIMT College of Engineering, Greater Noida. Today, I am discuss a most important topic in operating system, which is process state diagram and degree of multiprogram. Firstly, we discuss what is process state diagram or what is process, and what is the difference between process and program. Then we discuss one by one. Firstly, we discuss outline of the presentation. First one is the introduction of process state diagram. Second one is the pillar of process state diagram. Next one is the key point of diagram. And then next one is the what is process control block or PCB. And we discuss what is the PCB or process state diagram. What is, and next discuss process attributes. Then firstly, we discuss first point, introduction to the process state diagram. In process state diagram, there are 7 state. First one is the new state, second one is the ready state, third one is the run state, next one is the terminate state, suspend ready state, waiting state, suspend wait state. When a program is ready for executions, then they are goes through the following state: new state, terminate state, suspend wait state. These states are lie between the secondary memory of the computer system, and ready state, run state, waiting state is in between main memory. These states are lie in the main memory, and at the time the number of process present in the main memory at a time, the number of process present in the main memory is called as degree of multiprogram. At the same time, number of process present in the main memory is called as degree of multiprogram. Then we discuss these diagram one by one. In new state, firstly we discuss in new state. A process is said to be in new state when a program present in the secondary memory is initiated for the execution. That means we can say that in the new state, program are initiated, are created in the new state. In new state, program are created, are initiated for the executions. After the creations of program, long-term scheduler, dispatch long-term scheduler or job scheduler, it is also known as job scheduler, dispatch the program in the main memory or ready state. Then we can say that long-term scheduler increase the degree of multiprogramming because long-term scheduler keep the process from secondary memory to main memory or increase the degree of multiprogramming. Next one is the ready state. Ready state is the main part of the main memory, or we can say that ready state in live in main memory. A process moves from a new state to ready state after it is loaded into the main memory and is ready for executions. Means we can say that ready state is the part of main memory. A process moves from new state to ready state after it is loaded into main memory and it is ready for the executions. In ready state, those processes are present which are ready for executions, are waiting for the processor. In ready state, the process waits for its execution by the processor. That means total number of process which is present in the ready state is waiting for the processor for on executions. In multiprogramming environment, many processes may be present in the ready state. In multiprogramming environment, many processes may be present in the ready state. There are number of processes present in the ready state at the same time. Next point, we discuss run state. A A process moves from ready state to run state after it is assigned the CPU for executions. When a process are assigned to the CPU for executions, then he transmit from the run state to ready state, or dispatch from the ready state to run state, or dispatch from the ready state to run state, which is performed by the dispatcher, or it is also called as short-term scheduler. We discuss what is the short-term scheduler. Short-term scheduler is the main part of the operating system, or we can say that scheduler is the program of operating system. There are three types of scheduler in the process state diagram. First one is the long-term scheduler, second one is the short-term scheduler, and third one is the MTS. That means medium-term scheduler. So from short-term scheduler dispatch the program from ready state to running state for executions. In such scenario, any higher priority process are present in the ready state, then operating system interrupt the running process at the middle or preempt the process during the running time and move from ready state and move from run state to ready state, because a higher priority process are present in ready state. Then dispatcher dispatch these higher priority process for executions in run state. Next one is the terminate state. A process moves from run state to terminate state after its executions is completed. That means when the program are fully the executions of program is fully completed, then it moves from running state to terminate state. Without completions of execution, program cannot move from running state to terminate state. Program move from any state of the main memory, such as ready state or waiting state or suspense waiting state or running state. But when the program executions is completed, then program are moves from running state to terminate state. After entering the terminate state, the context or process control block of process is deleted by the operating system. When a process comes from secondary memory to main memory, when a process comes from secondary memory to main memory for the executions, one process control block are created by the operating system. We discussed what is the process control block at the last. When a process comes from secondary memory to main memory for the executions, operating system create a process control block for each process. Process control block is a data structure we discuss next. Then after entering the terminate state, the process control block of the process is deleted by the operating system. Next one is the block or wait state. A process moves from run state to a block or wait state if it require any input-output operations or some block resource during its executions. A process moves from the run state to block state or wait state if it is require any input-output operations, such as any types of resources, any types of printer, any types of software resources, or some other resources during its executions. Then process moves from running state to wait state. After the completions of input outputs, after the input output option gets completed or resource becomes available, the process moves to the ready state, not in running state. When the input output resources, when the input output operations of process is completed in the suspense or in the waiting state or block state, then after the completions of resources, the process moves to the ready state. Because when this process or either process comes in block state, the dispatcher dispatch the next process from ready state to running state, because dispatcher is the very fast scheduler, or short-term scheduler is a very fast scheduler. He dispatch the program from ready state to running state. Next, suspense ready state. A process moves from the ready state. A process moves from the ready state to suspense ready state if a process with higher priority has to be executed, but the main memory is full. At the some time when running state are full, ready state are full, then process arrive. Then long-term scheduler dispatch a program from secondary memory to main memory. and main memory are full and running state are full, then the process moves from the ready state to suspense ready state. These these process are these process are performed by medium term scheduler. Medium term scheduler is also known as a swapper. These these swapper decrease the degree of multiprogramming. These process decrease the degree of multiprogramming. Moving a process with lower priority from the ready state to suspense ready state creates a room for higher priority process in the ready state. Moving a process with lower priority from ready state to suspense ready state creates a room for higher priority process in the ready state. The process remains in the suspense ready state until the main memory becomes available. Means process are still in suspense ready state till the main memory are available. When a main memory becomes available, the process is brought back to the ready state by the medium term scheduler. These process, swap in, swap out process are performed by the medium term scheduler. Next. Sorry. Suspense ready state. Next. A process moves from the wait state to suspense wait state. A process moves from the suspend wait state to wait state to suspense wait state if a process with higher priority has been executed but main memory is full. Moving a process with lower priority from the wait state to suspense wait state creates a room for higher priority process in the ready state. Next one is the after resource become available, the process is moved to the suspense ready state. After main memory becomes available, the process is moved to the ready state. These processes are also performed by the medium term scheduler. In other cases, suspense may be created for ready, suspense may be created for or waiting state. Next one is the key point of the process state diagram. Next is the key point of the process state diagram. First one is a process is necessarily goes through a minimum 4 state. When a process are ready for execution, then the process are moves from the minimum 4 state. First one is the new state, second one is the ready state, third one is the running state, and fourth one is the terminate state. These are 4 minimum state. The minimum 4 state through which a process compulsory goes through 4. These states are new state, ready state, running state, and terminate state. However, a process also require the input-output operations. Then minimum number of state is 5. At the time of executions, any input-output operations are required for any process. Then the minimum number of state is 5. First one new state, second one ready state, third one running state, fourth one input block state or waiting state, and next one is the terminate state. Next, a single processor can execute only one process at the time. These are the main point of the process state diagram. A single processor cannot more than one process simultaneously. A single processor cannot more than one process simultaneously. Next, if n processor are present in the system, then only n process can be executed simultaneously. If 10 processors are present in the system, then only 10 processes can execute simultaneously. Next, these are the state, new state, present in secondary memory, ready state, present in main memory, running state, present in main memory, waiting state, present in main memory, suspense wait, suspense ready, and terminate state are present in the secondary memory. In process state diagram, these are the state, and there are 3 types of scheduler: short-term scheduler, medium-term scheduler, long-term scheduler. Short-term scheduler is also known as job scheduler. Medium-term scheduler is also known as swapper, and short-term scheduler, which works between ready state to running state, is known as dispatcher. And long-term scheduler works between the new state and ready state. Long-term scheduler choose the combination of two types of process. Long-term scheduler choose the combination of two types of process. Like input output one process, and next one is the CPU bound process. When long-term scheduler choose combination of those process, because if long-term scheduler, suppose we choose long-term scheduler choose the input output one process, then all the process goes through input output operations and running state is free. If long-term scheduler choose the CPU bound process, then CPU are overloaded. Running state, input output state is free. Then system are unbalanced. So long-term scheduler choose the combination of both process, input output one process and CPU one process. Next, we discuss process control block. Firstly, we discuss what is process control block and how it is created. Process control block. When a process comes from new state to ready state, or we can say in other words, when programs comes from secondary memory to main memory, then operating system create a process control block. That means when a process arrives in ready state for executions, then one process control block created by the operating system. Process control block is a data structure that store the information about a particular process. Then we can say that process control block is individual process. This information is required by the CPU while executing the process. This information is required by the CPU while executing the process. When the process are execute, then these informations are required, such as process ID, next one program counter, next one process state, priority, general purpose register, list of open files, list of open devices, protection. These informations are required during the executions. So we can say that when a program comes from secondary memory to main memory, then these informations keep in process control block. Each process is identified by its own process control block. Each process is identified by its own process control block. It is also called as context of the process. The process control block of each process reside in the main memory. Next, there exists only one process control block corresponding to each process. Okay. Process control block of all processes are present in the linked list. We can say that the process control block of each process reside in the main memory. Means every process is on process control block. If there are 100 number of processes in memory, then there are 100 process control blocks are created by the operating system. Individual process control block for each process. These are the diagram of process control block. There are some attributes such as process ID, program counter, process state, priority, general purpose register, list of open files, list of open devices, protection. These are the process attributes. Next, process ID. Firstly, we discuss what is process ID. Process ID is a unique ID that identifies each process of the system uniquely. Process ID is a unique ID that identifies each process of the system uniquely. A process ID is assigned to each process during its creation. That means when a process are created, then a process ID is assigned by the operating system. Process is the active entity and process is the part of the program. Program are present in the program is the set of instructions along with the data. But when a program are executed in the main memory, then executable part of the program is known as process. Then we can say that process is the executable part of the program. When a program when a program are ready for executions in main memory, then it is called a process. And when a process is created, then process ID is assigned to each process during its creations. Next one is program counter. Program counter specify the address of instructions to be executed next. That means we can say that those instructions which are executed next defined by the program counter. Before execution, the program counter is initialized with the address of the first instruction of the program. Before execution, the program counter is initialized with the address of the first instructions of the program, and then next instructions of the program, and then store the next instructions of the program, and then next store the next address of the program. After executing an instruction, the value of program counter is automatically incremented to point the next instructions. This process repeats till the end of the program. Next one is the process state. Each process goes through different state during its lifetime. Previously, we discussed all the state of the process state diagram. Next, process state specify the current state of the process. Means when the process in ready state or running state or waiting state or terminate or suspense block, suspense waiting state, in which state process are lying, the process state are defined in process control block. Next is priority. Priority attribute describe which process specify how urgent is to execute, or priority specify how urgent is to be execute the process. At the running process are lower priority, then higher priority process are interrupted by the operating system. The process with the highest priority is allocated to the CPU first among all the process. Next one is the general purpose register. General purpose register is also known as GPR. General purpose register are used to hold the data of the process generated during its executions. General purpose register are used to hold the data of the process generated during its execution. That means at the time of execution, general purpose register hold some list amount of data. Each process has its own set of register which are maintained by the PCB. Each process has its own set of register. That means every process has set of registers and which is maintained by the process control block. And process control block are maintained by the operating system. And every process has a own process control block which is stored in the main memory. Next one is the list of open files. Each process requires some files which must be present in the main memory during its executions. Each process requires some files which must be present in the main memory during its executions. That means every process needs some files such as input-output operations, such as any software resources, such as any hardware resources, and our other system loader or other any driver. Such types of files are required by the process during its execution. Then PCB maintain a list of files used by the process during its execution. So process control block maintain a list of files used by the process during its executions. Next one is the list of open devices. Then list of open devices. Process control block maintains a list of open devices used by the process during its executions. Similarly, open files. Similarly, the process control block maintain a list of open devices such as hardware types of devices such as printer, scanner, and other types of resources which is needed during the executions, which is already opened by the process control block. Because at the time of executions of process, these types of devices are need during the executions. Then these are the attributes of the process control block. we revise once. Process control block is the data structure, which process control block is the data structure which specify the some attributes, and every attribute has on role. And process control block created when a process are ready for execution or comes from the secondary memory to main memory for executions. And each process has on process control block. And each process has on process control block. If there are 10 number of processes in the main memory, if the 10 number of processes are main memory, then there are 10 numbers of process control block created by the operating system and keeps in the main memory. Process ID, program counter, process state, priority, general purpose register, list of open files, list of open devices are the attribute of the process control block. The major difference between process and program is process is the executable part of the program. Process is the executable part of the program, and program is the set of instructions along with the data. Program are present in the secondary memory, but process is present in the main memory. Program are the passive entity and process are the active entity. If there are 10 number of instructions in the program, which is stored in secondary memory, and in the 10 number of instructions, there 7 number of instructions are executed, then above 7 instructions is called as process. These are the common difference between the program and process. We can say that program and process are same. Only one difference is state of the program. If program are stored in secondary memory, then these are called the program. If the program are loaded in the main memory, then it is called a process. In the program, there are some number of process. Or process is the subpart of the program. At the sometimes process are divided into some part, which is called as thread. Or thread is also known as lightweight process. These are the common difference between process and program. Next one is thank you. Thank you, everyone.